Welcome back. Welcome back. We are going into domain 1, chapter 2 of the Comptia AI Plus. We'll be breaking down well, first in the last video we covered the difference between artificial intelligence, machine learning, and deep learning. If you missed it, check the link in the description box. Quick recap. AI is the big umbrella. Any system that acts intelligently. Machine learning is a subset of AI that learns from data. Today, we're going one level deeper into machine learning. We're answering the question, how does a machine learn? And there are three main types. There is supervised learning, unsupervised learning, and reinforcement learning. Let's break down each one, and they'll give you the decision that makes exam questions easier. We're going to start with supervised learning. So supervised learning is learning with a teacher who has the answer key. You show the AI model examples, and for each examples, you give them the correct answer. The model learns the relationship between the input and the correct output. This correct output, the correct answer is called a label. So supervised learning uses labeled data. Let me give you an example. Say you want to build a spam folder. You collect thousands of emails, and for each email, a human has labeled it as spam or not spam. You feed these labeled examples to your model. The model learns those patterns. For example, you can tell the engineer tells the models emails with quote free money quote tend to be spam. Emails from your contacts tend to not be spam. So if this was supervised learning, what would the machine learning proceed to do? The supervised model would then proceed to take what you input as spam and segment it into the spam folder. Emails from your contacts that are not spam, they would bypass those without giving them the spam label. Now, when a new email arrives, the model can predict spam or not. That's supervised learning. Now, supervised learning, to go a little bit further, has two main type of tasks: classification and regression. Classification is when you're predicting a category, such as spam or not spam, cat or dog, or malignment or benign. Regression is when you're predicting a number. So the key differences between the two types of supervised learning is classification predicts a category. It allows the model to predict a category for segmentation: spam or not spam, cat or dog, malignment or benign. Regression is when you're predicting a number. For example, let's say you want to predict house price of 25K. If you're trying to predict the temperature, if you're trying to predict a price, those are considered regression models. A simple way to ask yourself is to answer a category or a number. Remember that category equals classification. If it's a number, it's regression learning. A couple of real world examples of supervised learning are spam detection, credit approval, because it's a yes or no answer, diagnosis, price prediction, which would be example of regression, and image recognition. That's trained on photos labeled with what's in them. In all of these cases, it includes the correct answer. That's the hallmark of supervised learning, labeled data. All right, let's move on to supervised data, unsupervised data. Unsupervised unsupervised learning is the opposite. There's no teacher, no answer key, and no labels. You give the model a bunch of data and say, find the pattern. You give the model a bunch of data and say, find the structure. You give the model a bunch of data and say, tell me what you see. The model explores the data on its own and discovers hidden groups or relationships. Think of it like this. If you dump a box of random Legos of all shapes, sizes, and colors on the floor, and you ask a child to organize them, but you don't tell them how to organize them, they could group it by color, they could group it by size, or they could group it by shape. They're finding natural patterns without being told what to look for. That's unsupervised learning. The most common type of unsupervised learning is clustering. Clustering means grouping similar data points together. For example, an e-commerce store has millions of customers. They want to understand their customer base better, so they push out purchase history, browsing behavior, demographic data into a clustering algorithm, and the model can discover that group 1 are budget shoppers who buy on a sale. Group 2, the luxury buyers who want premium products, and group 3 are season shoppers who only buy during the holidays. Keep in mind that because this is unsupervised learning, we didn't tell them or give the groups labels. We just fed them all of the customer data we had, and the model proceeded to split it into group 1, group 2, and group 3. The company didn't tell the model these groups existed. The model discovered them. That's the power of unsupervised learning. Now, the subsets of unsupervised learning, just as you had regression and classification with supervised learning, the two subsets of unsupervised learning are classification and clustering. Classification versus clustering. Classification uses labeled data, so you do have predefined categories. You're sorting them into known boxes. Clustering uses unlabeled data. You don't have predefined categories. You're discovering new groups. So it's really taking the similarities. Clustering is taking the similarities and really predicting or taking a guess on what these groups have in common. An example of classification usually has categories already defined, and it still counts as which one? Would classification be unsupervised data, or would it be supervised data? Classification is supervised learning. Notice clustering uses unlabeled data. So there are no predefined categories and unlabeled unlabeled data. If the exam iterates, and it will iterate which one, if it says no predefined categories or no predefined discovery groups, automatically lean towards unsupervised learning as the answer. A couple of examples which are a little bit more complicated than supervised would be customer segmentation, anomaly detection, which finds unusual patterns in data, topic modeling, so discovering things in documents. For example, when we are using we just put all of our customer purchase information into the model. The model can then use unsupervised learning to split into who's more likely to buy again. They're able to see who's bought multiple times. They can see who shops more than who. You're able to learn a lot, but the model is actually predicting the differences and similarities between the plethora of customer data that has been given. Now, let's move forward into reinforcement learning. So, reinforcement learning is when you have an bear with me, when you have an agent that takes action in an environment to achieve a certain goal. It is very reward or penalty driven. For example, if an example of reinforcement learning is if you are training a puppy and you are training a puppy to sit, every time the puppy sits on that command, they receive a treat. Anytime you tell the dog to sit and you scold it, that is considered a penalty. That's a firm example of reinforcement learning. With reinforcement learning, you need an agent, something performing the activity, an action, what you want to accomplish, a reward, and a penalty. The agent's goal is to learn a policy, which is a strategy for which actions take. Going to define that for you. The agents or actors, in this example, it would be the puppy would be the actor, is to learn a policy, a strategy for which actions to take to maximize a reward. Here, a classic example, also a good example would be video games. When you have a video game character, let's say it's standing there, the environment is the game and the actions are the control. You can move, you can jump, you can shoot. The rewards are beating that level. Think of a Super Mario game. The reward would be reaching the flagpole at the end of the scroll Mario game, and a penalty would be losing lives or getting game over. That is an example of reinforced learning. More real world examples of reinforcement learning would be self driving cars. So, I'm going to do examples of reinforcement learning. You have the self driving cars, reward for navigating safely, penalty for collisions. You also have ad placement. So this is like running an A and B ad placement. Does the ad get more traffic and clicks at the top of the page, or does it get at the bottom of the page? From there, the model that makes the website will from then on create a policy to put an ad where it is most effective. Those are key reinforcement learning examples. Lastly, there is the energy management. So learning to optimize power usage. For example, if you connect if you want to use reinforcement learning to light a house, it would take into account how much energy it is to run certain rooms and which rooms you are using the most. All right, let's put all three side by side. So we've learned three things today. We have supervised learning, which uses what type of data? Labeled data. And this is when the teacher or engineer provides correct answers. It is used for predictions based upon past information and classification. Then you have unsupervised learning, when there is no teacher and the AI is taxed with finds patterns on its own. We use this for clustering and discovery. The example we use for this is when we use purchase data from a website, and then the unsupervised learning agent creates clusters or groups. Lastly, we have reinforcement learning, which would be if you're teaching a dog to sit, you reward it. And if you are teaching a dog to sit and it does not, it has to have one, an agent, two, a reward, or three, a penalty. And based upon the reward, or based upon how many times it's rewarded, or whatever reward you get it, it creates a policy to continue to be rewarded for positive behavior. I'm going to verbally share a few of the test questions from the Comptia that you might see. Ask yourself these three questions in this order. Is there labeled data? If there's labeled data involved, it's automatically supervised learning. Another question is the model. You need to ask yourself, is the model finding patterns without labels? Then it's automatically unsupervised. Is there an agent making decisions or receiving feedback? Yes. That's it. Three questions, and these three questions work every single time. So I do have some test scenarios for you. They're going to be attached to the study guide. But for that is your overview of the subcategories of machine learning. Thanks for tuning in. I look forward to having you join me for chapter 3.